Hi class, today we are learning how to solve quadratic equations that are not factorable. So on the first page of this note, we have an investigate that we will do tomorrow in class. So go to the second page where it says converting to vertex form. So one way to solve a non-factorable quadratic relation is to convert them into vertex form. You can solve vertex form because you can isolate x. Okay, because there is just one x, there's not an x squared and an x, so you can actually solve for x. So remember that you just need the a value and the k value, so the y value of the vertex, to know how many x-intercepts are in a relation. So why would you need to know the a value and the k value? Well, think about it. If you know that the y value of your vertex is positive and the parabola opens down, you know that you have two zeros. So this is a positive k value and a negative a value. Alternatively, if you know that your k value is negative, but your a value is positive, then you know you also have two zeros because the y value of the vertex is down here, opening up, which hits the x-intercept twice. Now, think about what has to happen for you to have 1 0. Your k actually has to be on the x-axis, and it doesn't matter if it opens up or down. So for there to be one x-intercept or 1 0, simply k has to equal 0. Doesn't matter about a. For there to be no zeros, you would have a positive y value of your vertex opening up, or a negative y value of the vertex, and it opens down. All right, so in this example, we want to determine how many x-intercepts each relation has, and then find them if they exist. So here our k value is positive, and our a value is positive. So therefore, there are no x-intercepts. Okay, since k is equal to 3 and the parabola opens up. Okay, in this next example, we have a k value of negative 12 and an a value, so it's negative, and an a value of 3, which is positive. So therefore, we have two x-intercepts, or two zeros. So to find them, you take your equation and you set it equal to 0. That's because the x-intercepts are the x values for which y is 0. So just a refresher, to do this, you move 12 to the other side. Don't forget the square. You then divide by 3. Then you take the positive or the negative square root, and you get your two answers from there. So x minus 2 equals 2, or x minus 2 equals negative 2. So from this, you get x equals 4. And from this, you get x equals 0. So those are the two x-intercepts. Now, from this process, we can derive a formula that we can always use to solve a quadratic equation as long as real solutions exist. So remember, there are either 0, 1, or 2 solutions to a quadratic equation. So to prove this formula, we complete the square on y equals ax squared plus bx, that's a square, plus c, and we solve for x. Okay, so first of all, this is our general standard form. And in the maxima and minimum note, we actually completed the square on this and showed that to put it into vertex form, this is what it looks like. So this is just taking the general standard form and putting it into vertex form. We did this in the maxima and minima note. So the first note of this unit, if you want to go back and find out where we got that from. So now we're going to come up with the quadratic formula, which basically takes this, sets it equal to 0, and solves for x. So this is my vertex form. Cassidy's in here. You want to be on the video? I'm literally recording right now. What's up? I just needed to know. All right, so here we go. So this is the vertex form. So this is a general parabola, and we're setting it equal to 0. So if we isolate x, that will give us a formula for finding the x-intercepts, okay? Knowing our b, a, and c from standard form. So the first thing you do is you take this minus b squared over 4a and this c, and you get a common denominator because you're adding those two together. That's the first step. Okay, so the denominator would be 4a. So we get minus b squared plus 4a times c all over 4a. That's the common denominator. Now I'm going to take this whole chunk and move it to the other side. Remember, I'm trying to get x alone. Okay, so when I move this over, it becomes plus b squared minus 4ac all over 4a. Okay, now I need to divide both sides by a. So that gets rid of it on the left side. Okay, remember dividing by a is the same thing as multiplying this by 1 over a. So I get b squared minus 4ac all over 4a squared, because I get a times a when I divide by a, and you get a squared. Okay, now I want to take the positive or negative square root. So I get x plus b over 2a equals plus or minus the square root of this whole thing. Okay, so now notice that 4a squared is a perfect square. So its square root is actually just 2a. So I'm going to move this b over 2a over, so I get negative b over 2a, okay, because I just moved it to the other side, plus or minus the square root of b squared minus 4ac, and I'm going to put that all over 2a. So I just took the square root of the denominator and simplified it, but I left it there on the top because I can't simplify that numerator. So now notice that they have the same denominator, so I can just write this as one big fraction. And that, my friends, is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, you will have that memorized very shortly. So let's fill this in here so it's very obvious in your note. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So what determines how many solutions there are is what's underneath the square root, okay? Remember, you can only square root a positive number. So if this, which we call the discriminant, so b squared minus 4ac is the discriminant, which means it's the thing that discriminates. It discriminates if there's 1, 2, or no solutions. So if b squared minus 4ac is positive, then there are 2 solutions. That's because you're going to add a number and subtract a number to get your 2 different solutions. However, if that b squared minus 4ac is actually equal to 0, then you will add 0 and subtract 0, which will give you the same solution twice. So in reality, there is just 1 solution. Now, if b squared minus 4ac is negative, that means you're trying to square root a negative, which won't work, which actually means that there are no solutions. So here's some examples. We're going to solve the following quadratic equations using quadratic formula. So the first thing that you have to have is that you have a quadratic in standard form equaling 0. So it has to be a quadratic in standard form equaling 0 before you can use quadratic formula. So let's identify our A, B, and C. A here is 2, B is 9, and C is 6. So those are the numbers we're putting into quadratic formula. So x equals negative b, so negative 9, plus or minus the square root of b squared, so 9 squared, minus 4 times a, which is 2, times c, which is 6, all over 2a, so 2 times 2. Okay, now I'm going to show you the best way to put this into your calculator. The best way is to just find what's under the square root first. So put in 9 squared minus 4 times 2 times 6 so that you get the discriminant. Okay, notice it's 33. It's a positive number, so we will have 2 solutions. And then simplify the denominator. Okay, if you do put this into your calculator at this point in one line, be very careful that put brackets around the numerator because both of them have to be divided by 4. If you put it in without the brackets, you'll only be dividing the root 33 by 4. Okay, so what you get from this is 2 different answers. X equals negative 0.814 and x equals negative 3.686. Try it on your calculator. Do negative 9 plus root 33 in brackets and divide by 4. Okay, you should get this number. Then do negative 9 minus root 33, enter, divide by 4. You should get this number. Here we have a little bit of an extra trick because notice that we don't have a quadratic equaling 0. We need to move this 8 to the other side in order to make that work. So we get 4x squared minus 12x plus 9 equals 0 because 1 plus 8 is 9. So now our A is 4, our B is negative 12, and our C is 9. I do encourage you to pause the video and try to do this on your own and then come back to the video to see if you did it right. So negative B is negative 12 or positive 12, plus or minus the square root of negative 12. Make sure it's in brackets, all squared. Otherwise, you'll get negative 144, and you want to get positive 144, right? It's negative 12 all squared. Minus 4 times 9, all divided by 2 times 4. Okay, remember, do what's underneath the square root first. You'll notice that you get 0. So that means that there's actually only one solution, which is 12 over 8, which simplifies to 3 over 2. A way you could have actually figured this out without quadratic formula is factoring this to 2x minus 3 all squared equals 0, and then solving for x equals 3 over 2. Either method works. Let's move on to a word problem, and you can see how useful this is in the everyday. The path of a basketball after its height is thrown from 1.5 meters above the ground is given by this equation, where h is height in meters and d is the horizontal distance in meters. How far has the ball traveled horizontally to the nearest tenth of a meter when it lands on the ground? So this is equivalent to solving the equation negative 0.25 d squared plus 2d plus 1.5 equals 0. Because you want h to equal 0 when it hits the ground. So now my a value is negative 0.25, my b value is 2, and my c value is 1.5. So I simply put that into the equation. Notice it's normally x equals, but in this case we are using d since that is the letter used for the independent variable. So negative b, so negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a, negative 0.25, times c, 1.5. All over 2a. 2 times negative 0.25. Okay, so again, you should do what's under the square root first. Negative 2 plus or minus square root of 5.5, all divided by negative 0.5. When you put this through your calculator, the first d value will be negative 0.69, and the second d value will be 8.69. This one is inadmissible because we can't have negative distance. So therefore we say the ball traveled approximately 8.7 meters to get it to our nearest 10th. Now find the horizontal distance when the ball is at a height of 4.5 meters above the ground. That is equivalent to solving this equation, negative 0.25 d squared plus 2d plus 1.5 equals 4.5. So let's think about what is different about this than our previous question. Well, here we have it equaling a number, which means we need to move it to the other side before we can use quadratic formula. We can only use quadratic formula when we have an equation in standard form equaling 0. So when you subtract 4.5, you get minus 3 equals 0. So now our a value is negative 0.25, our b value is 2, but our c value is negative 3. I invite you now to try to use quadratic formula and solve this for yourself. And I'll take it up in the next class. You should get two answers, d equals 2 and d equals 6 when you solve this. So it hits 4.5 meters after 2 meters, goes up and then comes back down, and will hit that 4.5 meters again after 6 meters away from the original. Please take a moment to review the success criteria and see how you feel about them right now. So, thanks for watching, guys. I hope you learned lots.